Let's begin by talking about the distance formula. If we're given 2 points on the xy plane, we can calculate the distance between them by using the Pythagorean Theorem. So let's go ahead and draw ourselves a little picture. We're going to put on the point A, which we will call x1, y1, and the point B, which we'll call x2, y2. And what we would like to find is we would like to find this distance from A to B, and we're going to denote that as d of A comma B. Now the reason I say we can use the Pythagorean Theorem is because we can create a right-angled triangle using the points A and B. And over here on the right-hand side, on this leg of our right-angled triangle, we could represent the distance of this leg as the absolute value of y2 minus y1. Similarly, this leg here at the bottom, we could represent this distance as the absolute value of x2 minus x1. Once we know these two distances, we can now apply the Pythagorean Theorem. We have that the hypotenuse, which is what we call DAB squared, must be equal to the sum of the first leg, y2 minus y1 squared, plus the square of our second leg, which is x2 minus x1 squared. And if we want to find DAB all by itself, we can of course take the square root of the right-hand side, and we get the following formula. y2 minus y1 squared plus x2 minus x1 squared, all underneath a square root. Now here, because distance is positive, we're going to take the positive square root and ignore the negative square root when we apply our square root. Let's find the distance between the 2 points 2, -3, and 6, -2. In order for us to use the distance formula that we created on our last slide, we need to figure out which numerical values are going to be x1, x2, y1, and y2. So let's call this first point 2, -3. We'll call these coordinates x1, y1, and we'll call this second point x2, y2. So now we can go ahead and make a substitution into our formula. We have y2 is -2, y1 is -3. And we have x2 is 6, and x1 is 2. So here we have -2 plus 3, that's 1. And here we have 6 minus 2, which is 4. One squared is 1, and 4 squared is 16. So this tells us that the distance between our 2 points is the square root of 17. Next, we're going to take a quick look at the midpoint formula for a line segment. So let's say we're given 2 points in the xy plane. Here I've called them A and B. And we want to determine the midpoint, or the halfway point, on this line segment that joins these 2 points. So I'm going to mark in where the midpoint would be in blue, so it might be somewhere in here. It's directly in between A and B, and we're going to call that M. Now we can calculate the coordinates of our midpoint by using the following formula. M is going to be equal to the average of the x-coordinates, so x1 plus x2 over 2, and then the average of the y-coordinates, y1 plus y2 over 2. To end off the lesson, let's calculate the midpoint between our 2 points 2, -3, and 6, -2. Just like in the last example, we're going to have to label these points. So I'm going to label this one as x1, y1, and this one as x2, y2. So now we can make the substitution into our midpoint formula. We take the average of our x values, so 2 plus 6 over 2, and the average of our y values. So here we have negative 3 plus negative 2 over 2. 6 plus 2 is 8. And here we have negative 3 minus 2 more. That'll give us negative 5. So our midpoint is going to be the point 4, negative 5 over 2. All right, my little epsilons, stay positive.